Thanks for tuning in to the Oxygen Alliance YouTube channel, where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell.
Hello, everyone, and thank you for joining us for week 16 of Concentrator Talk, brought to you by the Oxygen Alliance. My name is Amarpreet Rai, and I'm pleased to be hosting Concentrator Talk today from New York. I am joined by my colleague Timothy Matanga from Lilongwe, Malawi. For those of you that may not be aware, Concentrator Talk is a virtual meeting that the Oxygen Alliance hosts every Thursday from 2 to 3 p.m. Central African Time to discuss different aspects of oxygen concentrator assessment, use, and maintenance. Today, we are joined by technicians from both OpenO2 and Sanrai. We have Kulwinder Singh from Chandigarh, India. We have Mwawi Lungu, Mteto Sinjani, Cynthia Chikongomi, Sharon Ngozo, and Francis Sambani, all from Lilongwe, Malawi. Our first question today is, I was working on a Devilbiss 1025 UK oxygen concentrator, which had a damaged compressor start-run capacitor. I had to test the concentrator after replacing the capacitor, and I noticed that the concentrator was making some pulsating noise. What could be the cause of this noise? Maui, if you would be so kind as to take this question.
Thank you very much, Amapri. So if you refer to the service manual for this model of concentrator, so it's indicated that this problem normally develops due to a missing or defective intake filter, or if somehow you have a loose connection between the intake hose and the intake of the compressor. So apart from filtering the air, the intake filter also stabilizes the airflow as the air passes through the filter. So like if you open the intake filter and you look inside, you can actually see the filter paper inside and how it's laid out. So that helps to also stabilize the air, which reduces the noise. So when air is passed directly to the compressor without passing through the filter, the air enters with some pulses that could have been smoothened by the filter. So that results in the pulsating noise. So you have to make sure the working intake filter is in place and while you are running the concentrator. So just check your intake filter and make sure it's in the right condition. So sometimes the filter can be in place and the hose the pipe that connects the intake filter to the compressor might be disconnected. So also just make sure that that hose is also connected. So if you check these things and you see that there's a problem either with the hose or there's something wrong with your intake filter, just make sure you get this fixed, and that should be able to solve your problem. Thanks, Amapri.
Thank you, Maui. Does any other technicians have any comments, or do we have any questions from the audience? Okay, then we'll move to our second question. The question is, I am a biomedical technician working in Malawi. I have received an SKOC8 oxygen concentrator from Ikwanga Private Hospital that is displaying an E05, and the yellow light is turning on whenever the oxygen concentrator is turned on. I am currently searching for the manual for this oxygen concentrator. Is there anyone who knows the problem associated with this error message? Sharon, if you could take this question.
Thank you, Amapri. Okay, so the yellow light in this model is associated with abnormal temperature, pressure, and oxygen purity. But however, the error message displayed is only associated with high pressure that exceeds 260 kilopascals. So in this case, where both the yellow light is on and the error message E05 is displayed, it means the light is on due to high pressure in the system. So the high pressure can be due to several factors such as restriction in exhaust muffler, contaminated sievebed, for the solenoid valve, blocked airways, and for the circuit board. Therefore, you have to open the concentrator and check the performance of the mentioned things. So to start with the exhaust muffler, it may get broke with dust particles if the concentrator is being operated in a very dusty environment or the muffler has not been changed beyond its lifespan. So this makes less air leaving the muffler during purging, hence causing high pressure buildup in the sievebed. So this can be avoided by making sure that filters are connected in the system and replaced at the right time, and operating oxygen concentrators in dust-free environment. So you have to replace the muffler if not working perfectly. For the contaminated sievebed, if water gets into the sievebed, zeolite gets wet and airflow is blocked, resulting in pressure buildup in the compressor. So the same result develops when dust finds its way into the sievebeds. This can be avoided by making sure that working one-way valves and filters are pressed in the system. So you have to replace the zeolite or the sievebed if the zeolite is wet or dirty. For the valves, the solenoid valves may become faulty and block passage of air into the sievebed. Sometimes they may fail due to loose or disconnected electrical connection and being blocked by dust. So the breaking of airways leads to pressure buildup in the system. So you have to check electrical connections visually and check for continuity. And also you have to check if the valves are working perfectly. You have to check for airflow at the output of the valves. If you have any faulty valves, you need to replace them. Lastly, the further circuit board, the pressure in the system. So you have to replace the board if necessary. Thank you.
Thank you, Sharon. That was a very, very comprehensive overview of everything that could go wrong. Do we have any other questions or comments from other technicians or members of the audience? Sharon covered a lot. Okay, then let's move on to our next question. We have an auction concentrator that requires a replacement of an exhaust muffler. In our workshop, we have mufflers that are bigger in size and others that are smaller in size than the required muffler. Is it advisable to interchange the size of the muffler? If not, why? Mteto, would you please take this question?
Yeah, sure. So exhaust mufflers are designed to reduce noise during purging. So at the same time, they are designed in such a way that they do not restrict the air that is being vented out. So each model of oxygen concentrator has its own design to handle the air being vented and also fit in the physical space within the oxygen concentrator. So the image we're seeing there on the graphics is the muffler. One on the left side is one from the 515 Devilbiss concentrator, and the one on the right is the one from an ASF oxygen concentrator. So using a smaller exhaust muffler than the required muffler would create a blockage in the system, resulting in pressure buildup, which significantly affects the performance of the oxygen concentrator. And on another hand, using a larger exhaust muffler than the one that is required would simply mean it might not fit properly, since the concentrator comes in different designs and some models are smaller than the other. So with this in mind, it is possible that the exhaust muffler designed for one particular concentrator model might work without causing any issues to the performance of the concentrator. So in this term, we are talking about the oxygen purity, but it may not be able to fit physically inside the concentrator. So I would recommend that you use the muffler that is specified for that particular oxygen concentrator. Thank you, Amapri.
Thank you, Mteto. I actually will ask a question in case anyone else has any as well. Please feel free. From your explanation, I understood that if the muffler is a different size, the biggest issue would be sound. Like the noise would be, like if it's too small, the noise would be different, but there would not be an issue on the purity. Is that fair?
Can you come again there? I think I didn't get you. Sorry.
Yeah, I was asking that from your explanation, if the muffler was the wrong size, if it was too small or too big, the problem would be the sound level. It would not be a oxygen purity issue, right? Is that correct? Did I understand correctly?
So most of the times, like if it's on a smaller size, it means you need to vent out all the air, because if you don't vent out all the air, like creating the blockage, you are still keeping the nitrogen. So that might actually affect the purity. But sometimes you might get a muffler that is of a good size, but that is not designed to go inside, let's say, the Devilbiss 525. That works well, that you get the oxygen purity you're looking for. But now the problem is that when you want to physically mount it inside the concentrator itself, it doesn't fit. Yes.
Got it. Thank you. Any other questions or comments? Okay, then we will move to the next question. The question is, I am working on a Devilbiss 515 oxygen concentrator, and it has a rotary valve problem. At first, I thought the problem was the rotary valve, but after testing it on another oxygen concentrator, the rotary valve is performing. I am thinking the problem is the control board. How can I troubleshoot to confirm this? Sharon, would you please take this question?
Thank you. So there are two probable causes of your problem. It is either that you have a worn out or broken wire harness or a damaged control board. So to check if the wire harness connecting the control board and the rotary valve is broken, you should use a continuity tester or meter. So check that all the 9 lines are continuous. If found that one line is broken, use a soldering wire to fix the broken wires, remembering to seal the exposed wires with a heat shrink tubing or with insulation tape. So one of the main components of the rotary valve is the stepper motor. The stepper motor on the rotary valve has multiple windings, so there are several voltage readings that needs to be checked in order to determine if the problem is being caused by the control board. So testing for the proper voltage is done at the wire harness connector on the valve or on the PC board using a voltmeter. So the picture in the graphics shows the different voltages one is supposed to get. So as we can see all the graphics, you have a table and that shows the voltage readings you're supposed to get on various wires you're testing. So you need to note that the 2 to 3 volt leading will go on and off as the valve cycles. If any of these readings are not obtained, then the wire harness If any of the readings are not obtained, then the wire harness is not okay. You need to replace the main board, the main control board. Thank you.
Thank you, Sharon. We are now at our first poll. I am going to launch that. And Maui, if you would be so kind as to just give everyone a reminder of how to get to the polls while I launch that.
Yes. So if you are joining us from your mobile phone, if you go to the bottom right of your screen, there is a menus option there. So if you click on the menus option, another window opens up, and on that window, the activities button is one of the options listed. So if you click on activities, it should take you to a page where you have the pause menu. If you're joining us using your computer, then if you go to the bottom right of your screen as well, the last icon to the far right is the activities button. So if you click on the activities button, a window opens up and the pause menu is one of the options listed. Thank you, Amapri.
Thank you, Maui. So our first poll question is, did you know how to troubleshoot and fix the rotary valve of a Devilbiss 525? So far, all of the votes that we have are for no. So I think it was a good question that we answered. And more votes have come in, and they all are still for no. So I will now end this poll, and we will go back to our questions. So our next question is, the AirSep Intensity 10 LPM device keeps turning on and off unnecessarily. What could be the problem, and how can one solve this problem? Kulwinder, if you could please take this question. I think you are still on mute, Kulwinder.
Hello,
Hi, now we can hear you.
am I audible?
Yes.
So there could be different causes for this problem. One could be the degraded power supply sockets. This may cause unstable contact between the socket itself and the top plug. So the other reason can be the capacitor. If the run capacitor is not in good condition, then that will affect the performance as well. So measure the capacitor with the capacitance meter. If all is not well, replace the capacitor with the new one. So low voltage will normally affect the performance. If the voltage is low compared to the concentrator's operating voltage, the concentrator will not be able to run. For example, if in the concentrator is rated at 220 to 230 volt running, it below range will bring out undesirable performance. More concentrators can operate normally in the range of 195 volt to 253 volts in the 230 volt models, and in case of the 103 volt to 132 volt in the case of 122 volt models. So if there is a power fluctuation, so we must use this analyzer to minimize this type of problem, or we can check for any loose connections at the joints or the connections inside the machine also to overcome the problem. Thank you.
Thank you, Kulwinder. We have our next poll question, which I will launch here. And that is your local electricity supply voltage usually stable? I have my guesses for how this one will be answered. And while we are waiting for answers to come in, if anyone has any questions or comments about this question that we just discussed, the time is now to ask. Okay, no questions. And as I think we all could have guessed, there is only one vote for yes, and everyone else has said no. So I am very curious as to where the one yes vote came from with the stable electricity. And our next question. I am a technician at a district hospital. Yesterday, I received a Devilbiss MC44 from the male ward. The nurses complained that it was making a certain sound as if air was leaking. After troubleshooting, I noticed that the relief valve on the compressor was kicking in. This was caused by the faulty solenoid valve that controls the flow of air from the compressor to the sieve beds. I unscrewed the covers of the concentrator and I noticed that the solenoid valve was different from from the Devilbiss 515 and 525. There is a picture of the solenoid valve attached below. Please assist in explaining how this type of solenoid valve works and how it can be fixed. And I will ask Cynthia to take this question, please.
Thank you. So according to Devilbiss, MC 4490 service manual, the concentrator uses a pneumatic operated four-way valve that alternately distributes pressure supplied by the concentrator to two molecular sieve beds approximately every 11 seconds. While one bed is being pressurized, the other bed is being exhausted, and this is through the four-way valve. The exhausted gases passes through the four-way valves. These are directed to the manifold to the purge valve so that it can be released from the unit. The four-way valves, while operating pneumatically, uses the external pilot valve that allows pressure to shift the spools inside the four-way valve, and this pilot valve receives a signal from the concentrator board, causing it to open and allow the pilot pressure to activate the four-way valve. When the four-way valve activates, the right sieve bed will pressurize. Once the bed fills the oxygen accumulator valve, the cycle is changed by removing the signal from the pilot valve. This will cause the four-way valve to deactivate and pressurize the left sieve bed. It is no worth nothing that the four-way valve will not shift until the oxygen accumulator tank is filled. This would take approximately 11 seconds, depending to the altitude and liter flow. If the four-way valves do not shift, an alarm system will be activated, and a short or no cycle light on the MC board will illuminate. Lastly, if the alarm is not activated, short cycle times and low oxygen purity percentages will result because one sieve bed will continuously be pressurized. Thank you.
Thank you, Cynthia, for that comprehensive overview. So we have another poll question here that I will launch. And the question is, prior to this explanation, did you know how pressure-controlled pneumatic valves work? As we wait for the answers to come in, if anyone has any questions or comments, now is the time. And I am happy to answer that. Prior to Cynthia's wonderful explanation, I did not know how they worked. So I really enjoyed learning more about that. Okay, it seems like most people also did not know how the valves work. So thank you for that. And we will move on now to our next question. Our next question is, I am working on a Respironics oxygen concentrator that was malfunctioning. After troubleshooting the concentrator, I discovered that its fuse had blown out and I do not have a spare fuse to replace it. Is it proper to just use a wire in the meantime? Gowinder, if you could please answer that question.
Thanks, Ampit. So a fuse is a vital component in every circuit as it protects equipment and the various appliances. For PCBs, a fuse protects other components in a circuit. So a fuse breaks an electric circuit when there is an excessive current drawn by the machine. So its main component is a metal wire that melts when too much current flows through it. So fuses are manufactured with specific current and voltage limits. So different wires have different resistance and current ratings. Therefore, it is not advisable to replace a fuse with a wire. You might replace the fuse with a wire that will allow more current to pass through. That will result in burning other sensitive components that may be more costlier. So they may burn out the PCB boards or the compressors also. So it is not advisable to replace the fuse with a wire. So it is suggested to use a proper fuse rating. That may be maximum machines are using 2 amps fuse, 2 ampere fuse, easily available in the market. And it is also important that we should find out the reason why the fuse is blown off before replacing the fuse. Otherwise, it will blow off again if you put a new fuse if there is a problem inside the machine. Thank you.
Thank you, Gowinder, for that detailed explanation. We have another poll here that I will launch. And the question is, have you ever replaced a fuse with a wire? And while we are waiting for those answers, if anyone has any questions or comments, please feel free to speak up. Okay, this one seems a little bit more mixed. We've got almost 50% of votes on yes and 50% on no. So I hope we've now all learned where we can find a fuse easily to do that instead of using a wire. And as always, if there are challenges in finding components or items that you need, you can reach out to us at the Oxygen Alliance, and we are happy to help you find the components that make your life in maintenance a little bit easier. And I will now end this poll and move on to our next item, which is our topic of interest. So today's topic is flow splitter use and infection prevention. And Francis will be walking us through this topic today. So over to you, Francis.
Thank you, Amapre. So as she already pointed out, today we'll be looking at flow splitters. Flow splitters are exclusively used within the newborn and pediatric wards to deliver oxygen to several patients from a single oxygen source. So if we can look at the next slide. We have a picture. We have a picture of an oxygen concentrator, and to it is connected a flow splitter. And from the visualization, you can see that they're trying to deliver oxygen to 3 patients from one oxygen source. So that is the use of a flow splitter. You use one oxygen source to deliver oxygen to multiple patients. So flow splitters are just defined as accessory devices that divide oxygen from one source to several patients at independent and adjustable flow rates. So the maximum flow delivered per device depends on the model, but usually the range per flow meter on the flow splitter itself ranges from 1 to 2 liters per minute. So these flow splitters exist in two types. The first type being that they can either be adjustable or they can be preset. So by adjustable, we mean that the oxygen flow is divided by branching the secondary tubes from a primary tube with one end connected to the oxygen source and the far end connected to the last flow meter in the series of flow meters. So you have a series of flow meters. Can I have the next slide? Yeah, so the first picture shows the adjustable flow splitter, an adjustable flow splitter which has a series of oxygen flow meters. So you have a couple of them. In this case, we have 5, and they're aligned in such a way. I think we'll go into details as we go along. So the second type of a flow splitter is a preset flow splitter. So for these ones, the oxygen flow rates on each oxygen outlet are fixed. So these systems are usually fastened directly to the oxygen concentrator or an oxygen cylinder. So as we can also see in the graphics, we have a flow splitter fastened directly to the output of the oxygen source, in this case being the oxygen concentrator. And then, this means to say that you have a fixed flow rate on the outlet of each on each outlet. So for this one, I don't know what rate it was fixed on, but then it can be 1 or 2 or maybe 1.5 depending on the model itself as well. So in the neonatal and pediatric wards, the neonatal patients should reach SpO2 levels of 90 to 95% by 15 minutes after birth. If oxygen is needed, it is recommended to give between 0.5 to 1 liter per minute per WHO standard. So whilst on oxygen, regular monitoring should be conducted, including use of a pulse oximeter to ensure that this saturation range is maintained for the duration of treatment. So ideally, that means that a patient suffering from severe respiratory distress should have a continuous pulse oximetry monitoring throughout their medical care. So we'll go on looking at how the flow splitter itself works. So a flow splitter has internal tubing with individual flow meters that split incoming oxygen flow coming from the oxygen source. So the oxygen source might be a concentrator or maybe a cylinder. So oxygen flow splitters generally provide low flow rates, that is ranging from 0.1 to a maximum of 2 liters per minute from each port. The oxygen concentration delivered through an oxygen flow splitter remains unchanged from that of the source, meaning to say that if you have 95%, 95.6% of oxygen from the source itself, you won't have any less oxygen concentration from on the output of the flow splitter itself as well. You maintain the same concentration. So any discrepancies from the oxygen source or tubing circuit will affect the oxygen delivered at the outlet of the flow splitter. So that's also another point to note, meaning to say that if you have a leakage somewhere along the pipes, that should affect your oxygen concentration as well. So if I have the next slide, please. So this slide shows the external flow splitter components. So we have the oxygen source itself. So in this presentation, oxygen source is an oxygen concentrator, but it can also be an oxygen cylinder, sorry. And then you have the oxygen splitter itself has an inlet port. So that is where you connect the tubing from the oxygen source to. And then you have the outlet ports, which are on the bottom. So in this case, you have 5 outlet ports, and also you have a series of flow meters. So in this case, we have 5 flow meters, and this whole unit is known as the oxygen splitter itself. So next slide. So this graphic shows the internal components of a flow splitter itself. So it's usually just some T connectors or maybe Y connectors, I should say, and some tubings or pipe tubings. So the arrangement itself of the tubings matters in that it will class your flow splitter to either have an independent control or dependent control, which we'll soon look at. So it just shows the tubings, and then you have so this just shows the tubings itself, which is actually self-explanatory. So moving on, the typical design of a flow splitter should be designed to have independent flow regulation. Changing the flow rate at one port should have no or should only have a temporary effect on the other port. So this means to say that if you're trying to control the flow rate at maybe the far left flow meter, it shouldn't affect the flow rate on on any other flow meters. In this case, maybe let's say if you're trying to control the far left, none of the 4 flow meters on the right should be affected. So a flow splitter should have an independent control when you're trying to control the flow rate itself. So what determines this is the design itself. So as you can see, you only have an inlet from an oxygen source, and then you divide the oxygen going to each flow meter. You don't have the oxygen from the flow meter going back to the manifold itself. The manifold, which is the bottom layer, which acts like the main part from where the atoms take the oxygen from. So maybe we now look at independent flow splitter. So if flow splitter is designed in such a way that individual flow meters provide feedback into the general flow oxygen flow circuit, flow will be dependent. That means to say that as one port flow is changed, other port flows may also change. So this flow splitters should be changed for flow splitters with independent flows. As quickly as possible to ensure reliable treatment. So this shows the dependent flow splitter, and so this means in this design you have the oxygen from the flow meter feeding back to from where it was coming back from. So if you try to control one, and then you're trying to control one, the others change. That means to say if you deliver 1 liter per minute to a SMP, you have different flow now, and that is not what you want. So these are not advised. So if you are keeping these types of flow splitters, you should look for the independent flow splitter. So how do you set up a flow splitter if you have a patient? So the first thing that you should do if you're trying to set up a flow splitter is that you should ensure that the oxygen flow splitter is secured in a location where it cannot be easily, and where staff can easily view and adjust the flow meter located on the splitter. So firstly, the location itself, you find a good location where as staff can view and also can adjust the flow splitters. So in this first step, you're also supposed to open all the flow meters. So after you open all flow meters, you connect the oxygen splitter tubing from the oxygen outlet source to the oxygen splitter inlet port. So after you've connected the tubing from the source to the inlet port of the splitter, you have to assess the level of oxygen needed from the oxygen source. So the oxygen source, either it be a concentrator, a cylinder, or piped oxygen from the pipeline, must be adjusted to provide a flow of at least 1 liter per minute of oxygen, more than the total requirement from all the ports that are in use. So this means to say that if you have, let's say you have a flow splitter that has let's just use 3 flow meters that has 3 flow meters, and you're trying to supply 2 babies. That means you need, let's say you're supplying them at 2 liters per minute each. That means that's a total of 4 liters, and you have a 5-liter oxygen concentrator as your oxygen source. That means you should open the oxygen flow meter on the oxygen concentrator. It should be at 5 liters per minute, and you should make sure that the flow meters on the flow splitter should not exceed 4 liters per minute. So you have like a barrier of 1, as in you should open 1 liter more than what you want. So I think that's clear. So that is just, so you just do the assessment in this step, and then after you do that, you turn on the oxygen at the source, and then the flow meter beads on the oxygen splitter should pop out. So this step is actually very crucial, because it might also help you in detecting if you have leaks or not. So the first step, you have to open all the flow meters, and after you open all the flow meters, you connect the tubing, and then after connecting the tubing, you assess the level of oxygen that you need, and after you assess, you turn on the oxygen at the source. So in this case, since all the flow meters are open, if you have a leak, you won't have a bead in that flow meter popping up. So that will show, like, that will tell you that you have a leak maybe at the back of that flow meter. So this step is actually very crucial, that you open all the flow meters, and now it's the last step, that you can adjust the flow meter graders individually to the required flow rates. So using an example where you need 4 liters, and you have a 5-liter oxygen concentrator, you open the flow meter on the oxygen concentrator at 5 liters per minute. And then you close all the other flow meters and remove the 2 that you need to use and put them both at 2 liters per minute. So this is like the process of how you can set up the oxygen splitter itself. And the last step would be, okay, so I think we have a graphics, and let's look at that. Next slide, please. Yeah, so of course the picture is not clear. So the flow meter itself has like a plus and minus sign. So meaning to say, if you're turning anti-clockwise, you'll be increasing the flow in the flow meter itself, and if you turn clockwise, you'll be decreasing the flow. So the 2 directions just show that if you're trying to turn counterclockwise, you'll be increasing the flow, and if you turn clockwise, you'll be decreasing the flow. So that is just to show you that, to appreciate. And after you're done with that, you're supposed to number. So you're supposed to number the ports, the oxygen outlet ports, and also the oxygen tubing, to prevent the infants from receiving an incorrect flow. Since this the splitter is supposed to be used for multiple patients, there's a room for error, as in you might you might exchange the tubings, maybe it be the ports itself. So you're supposed to number them, that this port is receiving 1 liter per minute, and this tubing also is getting 1 liter per minute. So that makes you know that, okay, this is for this baby, and then this is also for this baby. You might as well go on and also numbering the I don't know what to call them, the trays, or where the babies are placed. Yeah. So a common problem that we've experienced in most health centers is that you have a user setting up the oxygen source maybe at 5 liters per minute, and trying to draw a sum of 5 liters per minute from the cell at the oxygen splitter itself as well. So now what happens is that as you're trying to adjust the other flow meters, the other flow meters will also be responding. You don't have that room for barrier. So as already said, if you want 5 liters per minute to distribute that to a baby, you should make sure that you have 6 liters per minute from the source. So that 1% barrier gives you like room for you to try to control everything well. So moving on to the last subtopic of today, which is infection prevention. So infection prevention and control is actually just a practical and evidence-based approach which prevents patients and health workers from being harmed by avoidable infection, and as a result of antimicrobial resistance. So routine and adequate cleaning of medical devices is critical to prevent hospital-acquired infections in newborn care units. So what must you do with flow meters in case you want to prevent infection? So what you should do is you should clean your hands with soap and water, or use 70% alcohol used on a patient. So before and after, you should make sure that you wash your hands with soap and water, or maybe use 70% alcohol. The second thing that you should do is you should ensure that all patient-related tubings are new and has been clean or have been cleaned thoroughly and dried as per reuse guidelines. So any patient-related tubing must be cleaned before it is used to place another patient on a nozzle prong. So nozzle prongs themselves are especially difficult to clean thoroughly. So that is just a side note for you. And tubings must be hung dry after disinfection and should not touch the floor or any other unsanitary surfaces whilst drying. So if you find that any item falls down to the floor and is contaminated, it must be cleaned thoroughly again. So the third thing that you can do is that the housing of the floor splitter should be cleaned according to WAD guidelines for disinfecting surfaces, or by wiping down with soapy water followed by 70% alcohol. So the floor splitter ports should also be cleaned using forceps, a forceps which is wrapped in gauze and also soaked in 70% alcohol. You should also clean any used equipment that has been in contact with the patients or staff. So these are like the 4 steps that you can look at if you're trying to prevent infection while using the oxygen splitter. So coming to this end, this brings us to the end of our subtopic. Thank you for your attention.
Thank you very much, Francis, for that explanation. Does anyone have any questions or comments? I think flow splitters, especially in infant wards or neonatal wards, are a really important tool. So if there are any questions or comments, please feel free to ask them. If not, we will take our last question of the day. And that is, I am a technician at a district hospital. I have been working on different concentrator models, and I have found that there are different types of solenoid valves used in these concentrators. Some of these concentrator models use rotary valves, while others use solenoid valves. What is the difference between the rotary valves and the solenoid valves? Sharon, if you could please take this question.
Thank you very much. Okay, so a rotary valve uses electric actuator control to achieve the valve opening and closing. It consists of a motor, rotor with vanes, headlights, and a housing. When the motor rod moves, it also moves the rotor, which has vanes. The vanes control the flow of air by either blocking the airway or opening it. So from the graphics, we can see a rotary valve. So for the rotary valve that is found inside a Devilbiss oxygen concentrator, a Hall effect sensor and a magnet are also incorporated. The Hall effect sensor tracks the position of the vanes by sensing the position of the magnet. So this allows the achievement of precise timed movement, which result in the control of airflow. So now talk about the solenoid valve. So from the picture, we can see a solenoid valve. So the other one is from a Devilbiss 515 and the other one from the ASEP concentrator. So these use an electric field to build the spool, thereby opening and closing the valve body. The coil power spool depends on the spring back pressure. So in addition to that, the solenoid valve switch is extremely faster than the rotary valve. Thank you.
Thank you very much, Sharon, for that explanation. I think we actually have time. We have a poll. So let me launch the poll. And while we're doing that poll, are there any questions or comments? And the poll question is, Have you ever replaced a rotary valve or a solenoid valve before? And we'll give it just a little bit of time to get that question answered. I think that's a fairly common part when we do repairs. So it seems like all of the answers so far are a yes. So let us take, I guess, one final question. And the question is, I am a biomedical engineer at a certain private hospital. I was working on a 515 Devilbiss concentrator. It was performing well after I finished fixing it, and it was giving out 92% purity at 5 liters per minute after a 2-hour test. A nurse came to collect it from the workshop to use it on a patient. When they switched it on and connected a humidifier bottle in the ward, the flow meter ball wasn't rising above 3 LPM. The ball could drop to 1 LPM, but couldn't go above 3 LPM. What could have caused this? And if Mteto, you would take this question, please.
Yeah, sure. So from the explanation, it shows that the problem came with the humidifier bottle that was connected. So when water in the humidifier bottle is not changed for many days, debris forms at the bottom of the humidifier bottle. So this debris is stirred every time oxygen passes through and bubbles are formed. So with time, they get stuck in the tiny holes of the filter. So the filter inside the humidifier bottle. So if the humidifier bottle is not cleaned thoroughly or regularly, the debris clogs up some of the tiny holes, thereby allowing a limited amount of oxygen to pass through. So to solve the problem, you need to empty the humidifier bottle and clean it, and then do some air dry on the humidifier bottle itself. And it is also important to note that changing the water in the humidifier bottle regularly and cleaning it thoroughly will prevent this from happening again. So it is also advisable to use distilled water other than using regular tap water. Yeah, thank you, Amapri.
Thank you for that explanation, Mteto. We have one last poll question that we will ask here. And the question is, do you understand the importance of cleaning a humidifier bottle regularly? I think we've all come across concentrators with humidifier bottles, either from patients or in the hospitals, that are quite dirty. So hopefully this gets a lot of yeses as well. And while we're waiting for some answers to come in, if anyone has any questions or comments on Mteto's explanation, now's the time. All right, as expected, we have a lot of yeses and no nos. So that is great. Hopefully we all have a little bit more information after that explanation when we're talking to nurses and hospital staff on why it's so important that we clean that humidifier bottle. And that wraps up today's Concentrator Talk. Thank you, as always, for listening along with all of us here today. If you have any questions, please feel free to reach out through our info@oxygenalliance.org website, or you can always review these presentations on our YouTube channel, or you can ask questions during the chat. So thank you very much, everyone, for your time, and we'll see you back here next week at 2 o'clock Central African time for the next Concentrator Talk. Thank you.